Analyzing the graph of a rational function. So here we're just bringing everything together now. So to find r of x equals n of x over d of x in lowest terms, you're going to factor. Then you want to find the domain of the function. Determine where your x-intercepts, if any, of the graph. Find the x-intercept is any number in the domain where the numerator is equal to 0, and the y-intercept is when you plug 0 into x of the function. Find any real zeros of the denominator by setting the denominator equal to 0 to determine the vertical asymptotes, and locate any horizontal or oblique asymptotes using the techniques from the previous lesson. Test for any symmetry by replacing negative x into x of the original function, and that will display if you have y-axis symmetry or symmetry with the origin. And then determine where the graph lies above or below the x-axis by using the zeros from step 3 and 4, and graph the asymptotes, if any, that were found in step 5. Plot the points you found in steps 3 and 4 and use all the information gathered to connect points of the graph. So we're going to use that procedure above to analyze the function and this graph below right here. So it says we're going to have r of x equals x squared minus x minus 20 divided by x to the third plus x squared minus 12x. All right, first things first, I'm going to factor this out because it says write r of x in factored form. So let's see what that reduces to. So I get x and x. I'm assuming this is a 5 and a 4. Negative 5 plus 4. That looks about right to me. In the denominator, I can take a GCF of x out. So I get x squared plus x minus 12. And I can factor x squared plus x minus 12 further, so I'm going to do that. Keep that GCF of x out in the front. Let's see. 3 and 4, so plus 4 minus 3 to get positive x, right? And then the x plus 4's go away. So I get x minus 5 over x times x minus 3. So r of x in factored form, I can make an r, there we go, is x minus 5 over x times x minus 3. All right, we good there? Okay, now we're going to find the zeros. The zeros are what's left in the numerator, so x equals 5. Find any values of x where r of x has a hole. The hole occurs at x equals negative 4 because the x plus 4 factor canceled out. Now, to find the y coordinate of that hole, I'm going to plug negative 4 in for x in my reduced factored form. So to find y, I'm going to do negative 4 minus 5 over negative 4 times negative 4 minus 3. So that's negative 9 over negative 4 times negative 7, which is positive 28. Let's see, negative 9 divided by 28 is negative 0.321. So my hole will occur at that x value in that y coordinate. Because it says find any values of x, I'm just going to leave that as x equals negative 4 for now. And then it says find any vertical asymptotes. So that's what's in the denominator. So at x equals 0 and at x equals 3. Okay, make sure you say x equals for your vertical asymptotes. Just don't write 0 and 3. And we have a horizontal asymptote. We gotta look at the degrees. So because I have x squared, let's make note of this. X squared is less than x to the third. That means I automatically have a horizontal asymptote at y equals 0. Again, don't just say 0, say y equals, because it is in line. All right, now it says state the domain of r of x. So the domain should be continuous from negative to positive infinity, except for where I have vertical asymptotes and holes. So if I think about number order, it would go -4, 0, and then 3. So I would have a break in my graph at -4 due to the hole. I would have a break in the graph at 0 due to the vertical asymptote, and then at 3 due to the horizontal asymptote. So the domain of this function would be negative infinity to -4. Show my break. -4 to 3. No, sorry, to 0. Forgot about the vertical asymptote of 0. See? All right, 0 comes before 3. And then I have a break at 0, because the vertical asymptote. And then I go from 0 to 3. I get stopped at 3 because I have another vertical asymptote. And then I go 3 to infinity. Okay, now it says sketch the graph of r of x and check your answer with the graphing calculator. So let's sketch what we know so far. So I have a 0 at x equals 5. So here's 5. I have a hole at -4, -0.321. So that's like right there. Very close to the x-axis. I have a vertical asymptote at x equals 0. And at x equals 3. I have a horizontal asymptote at y equals 0. Okay. And that should make sense looking at the domain. It goes from -infinity to -4, -4 to 0, 0 to 3, and 3 to infinity, because it can go through that 0 there. All right, now to get other points of the graph, remember you can pick x values to plug back into the equation. Because it says to check with your graphing calculator, just to save us some time, I did type the function into my graphing calculator and hit graph. Okay, so notice this is this part right here. We have kind of like a U right here, and then I have this part over here, okay? Now, a little trick I want to show you guys, you can plug in x values into the simplified function. If you guys just take a look here. So this is the original, and that's the simplified. Notice it's the same points. Okay, so just for purposes, I'm going to look at my table of values to get these points plotted. But you could type in the x values into here and find y coordinates to get an idea. You always want to pick x values, though, to each part of the vertical asymptote in the holes. So to the left of the hole, to the right of the hole, to the left of this vertical asymptote, to the right of it, to the left of this vertical asymptote, and to the right of that vertical asymptote. Okay, so plot some of those points there. Let's see, I've got 1, 2, 2, 1.5. So this kind of goes like this. Let's see here, at 4 it's -0.25. At 6 it's 0.05. All right. Now, one thing I want to talk about real quick is some of you are probably confused about why this graph goes through the horizontal asymptote. That can happen, okay? So when we think of asymptotes, we usually think of lines that graphs or functions approach but never touch. That's only true for a vertical asymptote. Graphs can go through horizontal asymptotes. So most of the time they won't, but do not be shocked if you see a graph go through the horizontal asymptote. It is possible. You should never, ever, ever, though, see a graph go through a vertical asymptote. So just be aware of that.